Good. So let's get started and talk about this is one of my favorite types of topics or types of sessions, actually, kind of a ranty war story session on enterprise cloud security, and very specifically on what can we do better, what can we learn from those different approaches. Very briefly from, if this thing works, let's see. I guess it doesn't. Magic. Okay. Very briefly from my side, I'm a consultant. I consult enterprises mostly, but also smaller startups who aspire to be enterprises at some point. So they have also enterprise-like requirements for some of their cloud environments. I've been mostly working with Azure myself for more than a decade now, but I'll try to translate on the fly into as cloud agnostic stuff as possible on any of those points when I'm actually going technical. So again, not working. What am I doing? Nope. There we go. So the plan for the session is to really get a quick primer, not on cloud security kind of technical topics. I'm not going to talk about what is IAM and what are some of the very basic tenets there, but really kind of get into the mind of what's happening from an enterprise's perspective with regards to cloud security, and how is that maybe different, or how is that handled in a typical organization that I've worked with. And we'll talk about this kind of basic problem area of the enterprise cloud security space. Then we'll take a look at some of those cloud security programs. How does that work from a perspective of, do we hire someone from the outside? Do we just get kind of some insurance? What are the options that are we going to do about it? And then we are going to look at a little bit more details into the architectural components of a typical cloud security architecture. How does that fit into an existing enterprise security architecture? And all along, I'll try to add some kind of reality checks and lessons learned throughout these different session parts as well. But really towards then, we'll also wrap this up on the last 10-15 minutes of the show. All right, so let's get started with the first part in here. And this isn't really a surprise to anyone who's here. We all saw this kind of barrage of memes about who was the biggest digital transformer, etc. for our C-suite. And it's not, of course, the CEO, it's not the CIO, it's the COVID-19. And basically what happened is that everyone who was hesitating of not going to the cloud at all needed to take the jump in weeks, maybe even days, and that meant that most of us, or most of the enterprises, went there fast. And then now all of us, from the security practitioner perspective, we needed to figure out how, now that we are here, how do we actually make this being here anyway secure? Whereas previously it was kind of analysis paralysis, that we were kind of just continuing to argue about whether or not to go to the cloud, when will we go to the cloud, etc., etc. Lots of different industries, of course, still are there. Still, not everyone made the jump with all of the workloads. But if your CEO is already checking their emails, chats, video discussions, etc., already on the cloud, you've already started to think about what is this split tunneling and all of this previously scary stuff. You kind of had to do it already. Then it's somewhat easier to kind of retroactively start thinking about how to start securing all of this. And really, these public cloud vendors kind of prove themselves in terms of the capacity as well, in terms of available kind of peak capacity. There were some hiccups on all of those, and especially also on the availability of these services. Very early on, in a couple of first weeks of the pandemic, for example, looking at Microsoft, they really squeezed down the limitations of, okay, you cannot really provision anything else if you're a totally new customer. If you already were on board, you had your enterprise kind of agreements, everything, you had your billing relationship supports, everything on there, you got priority. So they had the processes in place, and they managed to have also the physical capacity and the logistics in place to handle those new workloads as well. So basically the whole kind of cloud model is now kind of went from this kind of early innovator chasm and kind of made the jump on that early adoption curve, so to say. So we basically need to start thinking about shifting away from thinking about cloud security as something that is an isolated domain of information security. It's a specialization of someone, like we would have like application security or network security. It's someone's speciality. It's basically now something that everyone needs to understand up to a level, right? But also at the same time, the kind of traditional rules of an enterprise's point of view of having a trusted moat or a perimeter around our safeguards of data, that doesn't really fly anymore either. And we really need to start now talking about how do we actually secure those assets that have some sort of an exposure to the cloud side of things. And hopefully maybe the mindset has shifted that kind of cloud is not something that can be at most as secure as something that we can do on our own, especially on kind of or medium-sized organizations and up from there, but also something that potentially can be better than what we have in our own environments if we do it right. Of course, if we screw things up, then the exposure area is of course much bigger. So we need something called cloud native security. This is one look at this thing. Cloud native, of course, is also part of, it's not just containers. In my context, what I mean with cloud native is that it's specific to each of the clouds that you are working with. So if you are working with AWS, you should use the native tools and capabilities there. If you're using Azure, the same thing going on there. If you're looking at building a cloud native security organization, you need to start thinking about what are the cloud native skills that I need there. Do I actually need to ship all of my previous security architects into a cloud course? Most likely yes. But do they need to be purely cloud specialists by kind of completely forgetting what they did earlier? No, it's something in the middle. So it's kind of completely different set of approaches. We have less control available by default. We need to understand a ton of new product names within the individual clouds that we are working on. Even if we are dealing with only infrastructure as a service or platform as a service. Of course, then when we add software as a service on top of that, then, it's infinite. Then it's about identities, maybe barely some, there's identities, maybe some level of access control that we can add there to kind of at least bring our own identity provider. And then it's about almost going in the full legal and vendor management mode of trying to understand each of the software service providers and how do they run things. I'm trying to make this a little bit easier when we are trying to move our applications or infra to the cloud. Then we are dealing with provide CSPs like Microsoft, like Amazon, like Google, Ali, similars. So you need new skills. You need the skills specific to each of the clouds that you are using. Most likely you are using more than one. But my kind of opinionated part of this rant is really that you can do multiple clouds. You can do multi-cloud, but that just means that you need to have multiple single cloud expertise and multiple single cloud programs and people behind it. So it's this kind of rant of building it in, not bolting it on. So if you've seen any cloud security stuff, you've seen kind of the approach of cloud security is a shared responsibility when you move from left, right. When you move from on-premises, you have the most control available. You are also responsible of everything. If you move all the way on the spectrum to the software as a service side, you have the least controls available for you, mainly on the data and endpoint side. maybe on the identity, but everything else is done for you, and you can basically just do your due diligence or maybe get a better pricing tier, and that's about it. So most likely this is familiar to you if you dabble with cloud security overall. And a lot of the organizations do understand this, even if they didn't yet go to the cloud fully. What I argue is that you really need to, the point of the earlier slide saying that you also need to do this natively for each of the cloud and each of the cloud service that you are using within the cloud is that you really need to understand what does the shared responsibility model mean. Not just, hey, we are using Azure or we are using AWS, but for each of the service, what are the parts that are actually handled by us? And what are the parts that we are responsible for, and what are the parts that we can even control? Here's an example of managed Kubernetes services. There's different acronym for this from each of the cloud providers. And each of these have, of course, different ways of hosting the containers. But this is an example of something that sounds very much tempting in terms of, hey, we get to be in control of the workloads. We get unlimited scalability, and we also get someone else to manage the infra of our Kubernetes workloads. Well, in reality, we mostly only get a little bit fancier infrastructure as a service and just a teeny tiny bit of container as a service dabbled on top of it. Everything else is still our responsible. Most of these cases, AKS, EKS, and GKE, we basically just get a managed version of the Kubernetes control plane, which is the one that then goes ahead and does the actual orchestration, spins up new nodes, and then spins up new containers into those nodes. The nodes themselves are our responsibility. We need to either kill them off very fast and update them regularly, or depending on our maturity and depending on our approach there, we might need to actually think about hardening these, at least monitor what's going on in those environments. We saw earlier last year, for example, with the OmniGod on Azure side, where basically not all customers who were using these services understood that even though that Microsoft provisions, the CSP provisions a node that hosts your containers, and they provide you a patch for them, it's available, you still actually need to go ahead and kill those nodes and get those new nodes up and running. And that's all your responsibility, the bigger part of this beautiful, colorful display here. So kind of a little bit of an intro on the approach on the cloud security side. Then quite typically when we actually start thinking about, okay, now we have some budget. Yay, pandemic gave us budget. Pandemic gave us a way of, now we are in the cloud, we need to now actually secure this. Then what's going to happen? Basically, as with any enterprise, there's already existing set of people, there's existing vendors, maybe the CISO and the CTO have different budget than the folks who are driving the cloud. Of course, you need to put all of those in the same kind of internal political warfare. But if you're looking at this from the perspective that we already have an idea of what are we going to do on the cloud, we know that there's only one part of the organization who's handling it. We don't have any turf force or anything. Then it's basically about balancing the scales of these business needs of we need to be there fast, and we need to do whatever we do, AI, blockchain, whatever the latest hypes do we have in here. In addition to basically the ease of the shadow cloud. Basically, if we make this too hard, then our customers, the business, will just swipe their credit card and do their own thing in their own isolated environment, and we are none the wiser. On the other hand, we of course have our kind of existing security requirements that might need upgrading to this decade, or to even acknowledge the concept of us not understanding or us not being physically in the ownership of the whole stack end to end. And at the same time, we have more and more people coming in and taking potentially more risks in our environments. when a developer was working on, or any user was working on our own environment, we were basically able to limit the amount of damage when their environment goes boom. Then it was still within our trusted network perimeter and within our monitored environment. Now, if something goes wrong, they can potentially expose themselves to everyone on the 1/3 of the internet. Everyone is able to go ahead and download the IP address ranges for all of the major CSPs, and of course they are getting scanned and bombarded all the time. If you host your own whatever application in there, you can definitely do things the wrong way. And then all of this needs to of course fit somehow our existing security architecture as well. Typically, I see this kind of asymmetry of there's maybe one-to-many relationship of security architects versus cloud solution architects or cloud and even more cloud developers who might not even understand the cloud architecture part, let alone the kind of security implications of those. A lot of people seem to understand very well that those pricing models of different cloud services and architect stuff around those, but not necessarily the security parts. So basically, we need to start thinking about keeping our new security policies competitive and secure, or updating them in a way that keep us competitive and secure with this cloud move. So basically, again, if our controls are too strict, if we are too slow at providing those controls, the developers will start using those new cloud services themselves, either in our own environment, or if we really kind of go ahead and have this kind of a list of allowed cloud services in there, and we enforce that using some policies or other tools. Again, they have their option of just picking up a new cloud environment and doing all of that on their own, just for the development area. And the typical argument is that if we have this kind of pre-security verification of all security, all cloud services, then it always takes, because again, the asymmetry of less people on the understanding security than there are people who want to use the cloud. Because of that asymmetry, it will always take more time for the central IT or the security organization to catch up and provide those services. So we need to be fast, and we need to put on those controls that are minimally disruptive to the actual business, to actual use of those services, while still trying to balance all of our existing requirements on the security. So it's a lot about verifications, it's a lot about shift left and other approaches there. But this is the problem statement. And that's where we get into a cloud security program, which there's one example of that. Of course, as a consultant, I'll say everything depends. But basically, you need to have some sort of a cloud architecture. This is usually done within like a cloud center of excellence. This is maybe done according to the best practices of the vendor, according to your cloud well architected frameworks on AWS side, or CUF on Microsoft side of things. But basically, we need to have some sort of a cloud architecture. There might be other team already working on that. We need to update our cloud security policies, and we need to be able to start designing our cloud controls, at least for some parts of our environment. Maybe not everything that we already happen to have now with the pandemic there, but at least identifying our own crown jewels and going from there. As a consultant, yes, it always depends. There's always all nice different boxes. Maybe the anti-pattern that I see is that all of this part is done well. The upper part, all of the cross-referencing and mapping to external requirements. If this is driven by an internal audit or risk or compliance part of the organization, you'll have plenty of beautiful cross-references and plenty of beautiful Excel sheets. But you don't actually get any controls defined. You need to actually provide the real-time data from your CSPM, or you need to be able to define, kind of bridge the gap between your fancy governance models and your framework with the actual security controls that you have in place. And you need to get some visibility into this cloud security framework. So it's not a cloud security framework, which is part of the whole program. It's not an Excel exercise. It's not an internal audit exercise. That's a nice outcome of it, but it needs to be tangible. It needs to be a set of cloud native policies, for example. It needs to be a set of things that you deploy that actually control or limit what you can do in your cloud environment in a safe and agile and secure way. Okay, so to implement all of this, you need this cloud security architecture. Typically, these different components that you will see here include the landing zone or some sort of a secured cloud platform. What this really is basically, well, the only technical thing that we really have to have there is basically the billing relationship, so that our accounts won't be taken over if someone's credit card gets stolen or not updated accordingly. And everything else is basically up to what you are doing there. It can be a set of tenants. For example, on the AWS organization side or Azure side, you can define to trust a specific identity provider that you can then link with your existing IDP. You can bring in Azure Active Directory to both of those to control access there. It can be about all of that identity part. It can be about having some specific cloud architecture in place to enable networking, connecting actually back to your organization. The whole concept of the landing zone depends a little bit what you are doing there, and there are best practices and pre-populated stuff available for you there. But basically, it's either some infrastructure as code that you keep on updating and deploying, or it's at least someone did once this one VPN connection to our cloud, and then we have this one account or a subscription where we are deploying stuff, and everything more granular from there. And within that, there's different approaches, different concepts. You can use different cloud products, these different cloud services like Lambdas or ACI or AKS. And basically your cloud application or a cloud workload is just a collection of those. If you are a larger enterprise, or if you just buy like a large enterprise, you might want to have a customized versions of these products. So you might want to have your own repository of these same products, but with your default configuration. Maybe you have your built-in hardening there. You have the specific controls already inside those products. So you are not even letting your developers freely deploy stuff from the portals or consoles. You just give them a bunch of infrastructure as code and say, okay, this is our enterprise version of Lambda, or this is our enterprise version of RDS or Azure SQL database. Use this when you deploy, then you're golden. You don't need to worry about it. That again requires that we do all of this pre-work and keep on being faster than all of the requirements from our developers. Whichever approach you take, basically you will have some sort of a vague landings or some sort of a secured cloud environment that a bunch of people are going to deploy much more rapidly different cloud products into that. And they might even interconnect, even if you don't need to. So you need to have some sort of controls to put in place in there. Identity and access management is something that we always think in this landing zone. I mentioned that it can be just as simple thing as a tenant, where you have where it's connected possibly to your existing identity system. Here we need to think about how does all of this fit into our existing enterprise IAM processes. We bought ServiceNow a year ago. It was it's still ongoing, the implementation project. Now we are going to have plenty of new roles in this cloud world. We don't even know how many roles before we get started. So how does that pacing work together with these cloud requirements again? Do we need to think about separating admin credentials for cloud? Is our cloud tenant different from our is our business productivity tenant different from our apps and infra tenant? Do we have a separate Azure Active Directory or whatever we are using for them? Will we have different sets of access controls for or you will have different sets of access controls for the control plane or management plane of your cloud environment. So meaning who can go ahead and deploy those AKS, create and delete those clusters versus who can go inside those VMs, who can actually get those SSH keys or however you're authenticating there and actually make those patches inside those nodes. And the same is true with all of those different services that you're using. And you don't have this decomposition of control and management plane versus data plane before you actually do this bit of analysis of the shared responsibility model that we did earlier there. So all of this surprisingly connects. And then you need to think about external users. Do you have exactly the same set of external user or guest user onboarding? Do you still ship your company laptop to your external developers who are working on your cloud environments? If you do, then what's happening with your network controls again? Do you have a set of conditions that allow your developers to only access the cloud environment, the cloud console or portal only from the company network with all of those specific criteria being met? Maybe yes. Maybe that's going to take some time and you gradually will shift towards that. And then finally, how do you think about all of this when everything should be deployed not by developers going into a portal, but actually going through some infrastructure as code updates in your SecDevOps pipeline? And then you're basically, once you're done kind of hardening all of your accounts and subscriptions, you start to understand that there are actually more or less persistent access that you need to create to your deployment pipelines into those same environments that will have to have, by definition, a lot of power. They will need to have basically write access to create, read, update, and delete all of those resources in order to create, read, update, and delete your cloud environment. That's your data center now. It's completely defined as infrastructure as code. And, stay here in the room to check the next session, I guess, to how to do that. But from an infrastructure or from the IAM perspective, you don't have a single place where you can see, okay, who has root on my cloud subscriptions, because you will have that shared service principal or something else that is being used as the credentials of your whole SecDevOps pipeline. That might be a single user or a single service principal, or all of your teams might be sharing that. It might be, basically you need to combine your CI/CD access logs and access reviews together with your actual persistent cloud access controls and access monitoring in that. So it does disconnect and abstract it away, which means that it's more obscure, which means that more things can be hidden here. This is how, forgot the term, APT 2029 got in, basically by just piggybacking on existing service principles on Azure Active Directory that were created either by developers or just by business users when they were taking in basically software as a service applications and just saying, give me single sign-on to my whatever Hootsuite or whatever I'm using. Behind the scenes, if they had the power to do it in a self-service way, they basically got a service principal on the Azure Active Directory with fixed set of credentials. No one looked at those keys. It wasn't done centrally because, again, the first bullet or first box was integrating with existing IAM processes on our organization. No one looked at those things. When you actually got in there, you could regenerate your own permissions. You could generate your own keys to do other stuff in the same environment. And that brings us to detection and monitoring part, of course. Tons of logs, tons of new information that we didn't have before. We need to figure out where and how and if to store all of these things. We need to add machine learning to throw us some alerts from here. And we need to somehow integrate all of that with our existing SIEM and SOC. Which brings us to some sort of centralized cloud logging architecture. This is one example where the Azure logos, but the same is true with everywhere else. I mentioned that you will have at least one landing zone where you have those applications, those applications which are a combination of pre-built products. A landing zone can be a subscription or an account in AWS world, and most likely you will have some sort of a centralized one where you don't have all of your developers accessing your logs, and then you need to figure out how do you ship those logs from those more or less isolated application specific, or however you divided these those accounts and subscriptions. How do you ship those logs? Is there a cost impact? Is there a cross-cloud impact? Is there a retention or a compliance impact? And if I decide that I store more stuff in my application subscriptions in those log environments, that's great. That's more useful for my developers, and that kind of shifts the responsibility to them. But what if I need to do incident recovery? What if I need to do some sort of forensics work? Do I have a system in place where those centralized folks or whoever is that set of people who are doing this incident and forensics work, how will they get access to those isolated or decentralized logs? And is it an on-demand type of approach, or is it a persistent approach? If they have persistent access to my application logs, that might be hard for my certification or audit purposes. And there is still the networking question. It's not just one magical cloud. There is the cross-subscription networking, which I just kind of opened up. Do I send all of those logs on the previous picture across the backbone of my CSP? Or do I have some sort of VPN, or do I have something specific on the cloud environment to secure the connection in transit in a way that meets my compliance requirements, and in a way that doesn't add additional cost or slowness to the implementation there? What's happened if I need to use multiple regions of my cloud provider, and what happens if I need to transfer those into my own premise, need to do hybrid cloud connectivity? What if I need to do connectivity between my AWS, Azure, and Google environments? And what happens if one of my SaaS vendors is big enough that they warrant their own networking structure? If I'm using stuff like, I don't know, Palantir, for example, that's hosted in some one of these big CSPs, I need to figure out how do I get my existing landing zones in that CSP connected into that more or less multi-tenant or shared environment of my SaaS provider. And then, of course, we have this application level traffic. That's kind of something that we should be familiar with: web application firewalls, DDoS protection, etc. Only so the problem area is familiar. It might be the fact that everyone is doing this now in a self-service way. That might be the headache there. It might be the fact that we need to have some sort of way of controlling all of our rule sets, for example, across all of our web application firewalls, if we allow people to use their own. And how do we do this in a kind of cloud native way? Which brings me to the fourth part. I basically alluded to this. Animations are a bit wobbly. A little bit of spoilers there, but that's fine. I basically alluded to this first problem area of how do we integrate with our existing enterprise IAM. It could be that we have very elaborate processes, very elaborate tools already in place for each of the roles, for each of the applications that we might have. We might have done years of work on stuff like SAP, where we have very granular level roles defined very specifically what happens kind of in an end-to-end lifecycle perspective of privileged users, regular users, and all of those different roles. If they're externals, internals, what if they move to a different unit but still stay internal? All of that kind of existing work that we've done now somehow needs to catch up with the hundreds of different role types available on the cloud environments, and with the concept of not just having this one landing zone level role, which is kind of a DC admin type of role, but going very, very granular, potentially even in the level of a single cloud database resource that we have might have their own role types available for them. And our typical database admin might need that role, but they might also need a reader role in a wider scope. And that's basically the kind of the business role composition becomes a very taxing process if we want to do it exactly the same way and as manual as we did for all of this existing stuff that we had. The same goes again with these unmanaged accounts, especially these service principals, similar type of accounts where when the first time you started using your cloud environment, you asked, like, hey, can I get a service account created for my AWS account, or service principal created for my Azure subscription so that I can deploy my CI/CD from there. If you don't, by default, if you don't do anything, and if it's old enough, those certs basically, or those credentials basically don't expire. You need to manage those credentials. How do you actually get access there? Nowadays they fixed a little bit on some of these, so the default expiry dates in GUI are short, but there's no such thing actually. For example, on service principal side, there's no such thing on the actual API level. So if you still have the same code that creates them, you're out of luck. And again, our guest accounts, federated accounts, if we buy or sell a part of our business, we need to maybe carve out a piece of our identities there as well. So you basically need to create some sort of a concept of a cloud account vending machine that gets your developers some sort of a self-service way of getting access, getting the proper type of access, maybe even defining that access on their own. Instead of you doing that pre-work for them, maybe they just submit a pull request and the security work is actually you reviewing the specific role description and doing that analysis there, rather than you trying to figure out before they use what type of roles they should be getting. And then automating that. So trying to speed up. On the multi-cloud side, and even in a single cloud, multi-subscription, just a larger environment, inventory and asset management becomes a big question, because we don't know might not even know what we need to control. We might not, if you recall that Omigod case, we might have had the idea that we had a ton of VMs in our environment, but did we have an inventory of all of those cloud solution provider provisioned agents and configurations on those images that were provisioned for us? Did we have an inventory of all of the versions that are deployed there? Was that up to date? Did we understand that we are the ones who need to patch that? Sometimes yes. Containers seems to be pretty much the standard way of deploying stuff now. That's great. We need to understand if you have a kind of modern CSPM there, we have most likely great scans available of the vulnerabilities of the containers when they were created or built. Are these alerts now relevant still 5 years later or a year later? Which of these images are we actually running in our cloud, and how do we make that connection? That's the part that we do need to figure out again. Are we doing this in a cloud native way, or are we doing this in the kind of using the tools provided by the cloud vendor, or do we need to somehow integrate that tool into our existing that information into our existing inventory and asset management? Basically, do we have some sort of a webhook that whenever we deploy a new container in our thousands of different subscriptions in some managed Kubernetes cluster, how do we get that information of a new pod is pulling in a new container image? How does that information get into our SBOM, whatever we will have in the future of a collection of what are we actually using in production right now? There's new vulnerabilities in CSPs. We saw both on Azure, we saw on Cosmos, we saw on AWS, we saw on Lambdas. There's tons of new vulnerabilities. As there's more use, we get more disclosures of new vulnerabilities of the CSPs themselves. And again, we need to understand what have we configured that has been our responsible, And now that we haven't done any controls ourselves on the part that they were responsible of, we basically just need to understand what is the impact, when are they going to patch that, and is there an impact for us? And then we had these new signals from cloud health, kind of new maintenance events, new scaling events, all of those events. It's very hard to kind of find any type of insights from that noise. We need to basically take into some new products which have machine learning and all sort of pre-filtering and playbooks available in there. We talked about shared responsibility. We talked about Omega quite a bit. And this concept of we are just doing this for them. We don't need to do this properly because we are not yet using production data. Well, attackers of course don't care, and also the public doesn't care if whenever you have a management port publicly open in your environment on the public cloud, and that is somehow linked to your business, there's still at minimum the reputational risk, if nothing else, in there. And believe you me, you will be found out. Whenever you provision something within 5 minutes, you will have everyone knocking on your door there. And this is basically where this software bill of materials could maybe help potentially. Let's see how do we get better integration from all of our different vendors in this space. 2 minutes for Q&A and very fast switch of a speaker at the same time. Thank you very much, and I'm going to take some questions.